Today we are going to see the Hurwitz polynomial. Now what we see in Hurwitz polynomial, this is your Hurwitz polynomial. Now suppose PS is your Hurwitz polynomial, I is equal to 0 to n ai si. This is a Hurwitz polynomial. Means what must be the case for the polynomial PS to be Hurwitz? The coefficient this ai, it must be real and positive, and this is the first point. And the second point, the root must not lie in right half of plane. Now here we got this one ai, it must be real and positive. Suppose I am taking root. If the root lies in left half of plane -2 and -3, then what will be our equation? S plus 2 and S plus 3. Now if I multiply these two, because S plus 2 and S, if I multiply S square 3S plus 2S plus 3 S square plus 5S plus 3. Now this is your equation. Now if you see the coefficient of S square is 1, coefficient of S is 5, and coefficient of the zeroth term is 3. These all are positive. These are called AI. This is AI. Now suppose the root is in left half of S plane. Now suppose I have taken at these 2 points, the root is there. Suppose as plus 3 and 5. Now if I make the equation of this one, then it will be S minus 3 and S minus 5. Now if I multiply this one, this will become S square minus 5S minus 3S plus 15 S square minus 8S plus 15. Now if you see, now this we call this as, this will be not Hurwitz polynomial because the root is in right half, and when the root is in right half, then what we are noticing, the coefficient is negative. The coefficient of one of the coefficient is negative. It means for Hurwitz polynomial, so for the polynomial to be Hurwitz, it must have the real, this ai must be the real and positive, and the root should not lie in right half of plane. Now we are going to take one equation and we are going to see. Now suppose PS is this one S cube plus 2S square 3S square plus 2S plus 1. Now this is your equation. Now what we are saying, the coefficient is positive, but we need to verify this one ai is. Now we will verify how to verify this is Hurwitz or not. Then we must have to make the successive division of odd by even or even by odd. Which term is, if you take the even term, odd term out, then what is this odd? PS of odd will be S cube plus 2S, and PS of even will be 3S square plus 1. Now this is your even. Now what we need to do, we need to divide 3S square plus 1 with S cube plus 2S. Now when you divide this one, how you will divide? This will be S by 3. Now if you divide it, this will become S cube plus S by 3. Now if I take, this will cut out, this will cut. Now if I subtract, then it will become 5 S by 3. Now this is the remainder we got, and with this remainder again we have to divide to this one, 3 S square plus 1. If I again divide, then this will become 9 by 5 S, and then this will become 3S square and if you see, this will be cutting. Now remainder 1 we got. Now divide by 5 by 3s. Now this is 5 by 3s, 5 by 3s 0. Now we see this term, this is the quotient we are getting, and these are the remainder we are getting. If this is the positive, if this all this is positive, then we can say this as a, we can say this as a Hurwitz polynomial. And the shortcut method to find this Hurwitz polynomial, what we will do, we need to make one chart. We have to take this one odd. If it is the odd, then we are going to take odd. This will be s cube and second will be s square. Just as RH criteria, root Hurwitz criteria, we are going to do in that manner. S cube and the coefficient of will be 1 and 2, and this is 3 and 1. And for S1 coefficient, what we are going to do, 3 to just 6 minus 1 by 3. 3 into 2 minus 1 into 1 by 3. What it is going to give me? 5 by 3. This is 5 by 3. Now for S, now this we are multiplying, we are doing the multiplication. This into this minus this by this term will give me S1 term. This is 5 by 3. Now in here, this is nothing but your 5 by 3. Now what we are going to do, and what will be this term? This will be 0. Now again multiply 5 by 3 into 1 minus 0 into 3 divided by 5 by 3, it is going to give me 1. Means 5 by 3 into 1 minus 0 into 3 by 5 by 3, it is going to give me 1. Or if I check, this magnitude has become, this magnitude has become 1. Now you just see the first column, 1, 3, 5 by 3 and 1. If this is positive, then we can say this as a Hurwitz polynomial. Now if you see what is relation between this and this, now if you take the division of this one and this one, this will be s cube, 1 into s cube, and second term is 3s square. Now if I divide these two, then what I am going to get? S by 3, and same we are going here getting S by 3. Now if I divide this by this one, 3s square divided by 5 by 3s, then this s will come and this will give me 9 by 5s, and this is your 9 by 5s. Now this term is nothing but the division of 5 by s into 5 by 3, 5 by 3s divided by 1. Now this is 5 by 3s. Now this is from here also we are getting the same thing. Means if you divide, you are going to get the quotient. And if you see, what is this 3s square plus 1? If I see 3s and the next power will be s to the power 0, so it will be 1. Now if I see 5 by 3s, see this is 5 by 3s, now this will be 1. So these all are just the value that we are going to get. Now what we need to check for that is the first column must be positive and it must not stop in between. Suppose if it stopped at S3 or S1 only, then we are again going to check with the different, with the polynomial that we are going to see the next cases. Now take another sheet. Now if I take a function ps is equal to s to the power 7, 2s6, 2s5, s4 plus 4s cube and 8s square plus 8s plus 4. Now if I take this equation, then what we need to do, we just need to take the even odd term out. Odd will be as of 6, 2s5 plus 4s cube plus 8s. This is the odd term that we have taken. Now if you take the even term out, now what is the even term? 2s power 6 plus s power 4 plus 8s square plus 4. Now I need to divide which one is the lowest factor. Even term is, now we need to divide even by odd. Now if I do the division, 2s power 6 s4 8s square plus 4 with the s7 2s5 4s cube plus 8s. Now if I divide it by half s, then what we are going to get? s7 s cube by 2 plus 4s cube plus 2s, and if I subtract this one, what I am going to get? This will be cancelled, and 3 by 2 s5 plus 6, this will be cancelled, and 8 minus 2, it is going to 6. Now I am going to divide this with this one. Now writing whole expression, 2s6 s4 8s5 into 4, and this will be your 4s by 3. If I divide 4s by 3, then it is going to give me 2s6 plus 8s square. Now this is going to get 8s square. This is your square only. Here 8s square, this will get cancelled out, and lastly we are going to get s power 4 plus 4. And what we need to divide? We need to divide with the 3 by 2 s5 plus 6s. Now this is the expression we are. Now what we need to divide here? If I divide with 3 by 2 as, then what I am going to get? 3 by 2 as 5, and if I do here, then it is going to give me 6 as. Now if I subtract, you are going to get 0. Now I cannot divide. But if you see, this is a 7 term, means 7 factor we must get, but only we are going to get 4 factor. This one 1 2 3, we are seeing this as a positive. Then also we cannot say this is Hurwitz or not. For that, what we need to do, we need to again check this value, that the last product that we got, s to the power 4 plus 4, this is the last product we are getting, last divisor we are getting. This we need to check. And if you check the s power 4 plus 4, it has 4 root, this one, this one, this one, simply, and the root lies in right half of plane, so this is non-Hurwitz. Now if you check it by division method, then how you will check 4 as 4 plus 1 plus 4, that we will be doing later. But if I do it with Hurwitz equation, then what we need to do, I am just taking this, and if I will be writing this Hurwitz polynomial, then what will be? P odd s to the power 7, it will be 1 1, first coefficient 1 s to the power 5. The second will be the lesser, 2 lesser, that will be 2, means s to the power 5. This will be 4 8, means by looking at this, and if this is there, then what we will be write s to the power 7 2s 5 4 as q and 8 as, this will be it will be subtracted by the -2 term everywhere. Now as per power 6, what will be 2? 2, 1, 8, 4. Now for as per power 5 term, what we are going to do? We are going to apply 2 to 4 minus 1 by 2. It is going to give me 3 by 2. 2 4 is 8, 8 by 1. This is going to give me 0. 2 8 16 minus 4 12 by 2. It is going to give me 6. Now as to the power 4, 3 by 2 into 1 minus 0 into 2, it is going to give me 1 only, and 3 by 2 into 8, it will be 12. 12 minus 12, 6 into 2, it is going to give me 0. 3 by 2 into 4, it is going to give me 6, and here it is 0. 0 into 2, it is going to give me 4. Now if I try to proceed further as 3, 1 into 0 minus 0 into 3 by 2, it is going to give me 0, and then this term will be also 0. So I cannot proceed further. From here we came to know the last product, the last divisor is s to the power 4 plus 4, and from this continued division we got it as to the power 4 plus 4. Now we need to check this polynomial, and what is left with us, the remaining polynomial. This, if I multiply this with the remaining polynomial, then we are going to get the total polynomial. Now how we are going to check as to the power 4 plus 4 is Hurwitz or not? Then for that, what we are going to do, we are going, suppose we need to check this function as per power 4 plus 4 is Hurwitz. For that, what we need to take, now suppose this is a difference function, then take the derivative of this one. This will be 4 as cube, and derivative of this will be 0. Now if I divide this with the upper one, then we are going to again get the result, 4 as cube divided by s to the power 4 plus 4. Now if I divide by 1 by 4 as, then this is going to give me s to the power 4, this will be 0, and if I divide with s by 4, then here we are going to get the term 4 by s cube into s to the power 4. This is the term that we get, and lastly what we are going to get, 4. This is 4, and this will be 4 s cube. Now if I divide with this one, how I am going to take s cube, this will be 4 s cube. Now if I subtract, this is 0. Now what we are going to see here, that now if you see here, we are going to get 0 and then with 4. Now if you see here only, you got it, this is not Hurwitz, because here it is 4 s cube, and now directly we got it 4, means s to the power square term is missing. It means it is not Hurwitz polynomial. Now this we can see from the successive division that we have done. See, if this is s to the power 5, here what we are going to get, s to the power 4. It means one magnitude lesser than. Now if you want to check by RS criteria, that we need to check 4 s cube s to the power 4 plus 1, then p dash of s will be 4s cube plus 0. Now if I make this graph as to the power 3, 2, 1, 0, 4, and this is 4, 0, 0, then what will be s square? S will be 0, and what this is going to come as 1, 4, 4 into 4 16 minus 0 by 4, it is going to come. Now if I check s1, 0 minus 4 by 0 means this term is coming infinity, means it must be the first, this term must be positive, but this value is coming infinity. That is why it is not Hurwitz polynomial. So this is all about the Hurwitz polynomial. Suppose if you have, if I take one more example, suppose if I take one more example, PS is equal to s to the power 4 s to 1. Now we don't know how to proceed because we are not going to divide with the, there is only even term. Then what we are going to do, we are just going to differentiate this function. What will be 4s cube plus 2s and then 0. Now if I do the division method, then it will be very tedious. Now solve it by this. This is your s to the power 4 term and this is your s to the power 3 term, and the remaining, this is 1 1 and 1, this is 4 2 0. What will be s square term? 4 1 is 4 minus 2, 4 minus 2 by 4, this is going to give me half, and 4 1 is 0, this will be giving me 1. And what will be s term? Half into 1, half into 2 is give me 1 minus 4. I am going to multiply this, subtract with this one, by division this one, it is going to give me minus 3 by 2. Now we have seen the first term, we got a negative sign, so this will be not Hurwitz. Now this we are saying that the negative sign we have first established only, we must not get the negative sign, that is why we are checking. Now if you see this, here we told that this AI must be real and positive, so we are seeing the first column must be positive. So by this we can say the polynomial is Hurwitz or not. Suppose the function is PS is, now function is hs by qs, then how we will find that polynomial? Just add this one hs plus qs and then find out it is polynomial or not, it is Hurwitz or not. By this method, then easily we can see it is a Hurwitz or not. So this is all about the Hurwitz polynomial.